Hi everyone, today we are going to do the applying ID3 and SVM algorithms to the breast cancer and CIFR 10 image datasets, which can either be loaded using Scala or Eraso, and we can download these two datasets from uh, these two links. Uh, I have already downloaded these two and replace the null values into the zeros, and we are going to uh, check the two algorithms ID3 and SVM for the two different datasets for the breast cancer and CIFR10. Uh, First, I go for the breast cancer dataset. In there, we imported the libraries like pandas and numpy, matplotlib, matplotlib, and cboa, and then we loaded the dataset through scale and dataset. We load breast cancer dataset into the variable called cancer, and we set the data frame columns data and target. With when the dataset columns with feature names and target, uh, we can see at the end target column has appended with zero values. And if we check the data frame shape, it's 5, 6, 9 rows and 31 columns. And when we consider the columns of this data frame, there are mean radius, mean text, and there are many columns are available. And then we plot out just the first 5 variables features to check the explore about this data. There we can see mean radius into mean radius and mean texture into mean texture, how they different with colors. These two different color source, if that this one is orange, it means no cancer, and if the looks blue, it's being getting into cancer. So we can have this data set separated into two clusters. And here we visualize our counts from blue count. There are 240, right? And from orange color, there are 350 colors. I earlier told that from orange, it's no cancer. Means there are a lot higher amount is from no cancer. And we check the correlation between the our features. We can see different values. I mean, radius one like that. We check the correlation. And after we check the correlation, we drop out our target features and use all the remaining features in our data frame to train the model. Then we create the training dataset and testing data. Now that we have assigned values to our x and y, then next step is to import the Python libraries, and that will help to split our dataset into a training dataset and testing data. That it means training data means is the subset that our data used to train our model, and testing data is the subset that of our data that the model hasn't seen before. This is used to test the performance of our model. Here we split out our data set into 80% for training and remaining 20% for the testing purpose. Here I imported the support SVM model through the scalar, and then train our SVM model with our training dataset. And we can see our train model to make prediction using the testing data. Next step is to check the accuracy of our prediction by comparing it to the output we already have. We are going to use confusion matrix for this comparison. The confusion matrix is a table representing the performance of your model to classify the labels correctly. You can see a confusing table there. It's very clear to understand. We can see a predicted cancer amount and predicted healthy amount. To the is there is already cancer or is it is already health. So to do that, we need to create the confusion matrix. The confusion matrix is a table representing the performance of your model to classify labels correctly. Confusion matrix for a binary classification task. In a binary classifier, the true class is typically labeled with 1 and false. Class is labeled 0. And true positive, false negative, true negative, false negative. And there are 4 sets can be taken. And columns of the confusion matrix sum to the predictions by the class. Rows of the matrix sum to the actual values with each class. You may encounter confusion matrix where the actual is in columns and the predicted in the rows. The meaning is the same, but the table will be reoriented. And then we go into create a confusion matrix for our classifiers performance on the test data set. Here we imported matrix classification report and confusion matrix using scalar matrix, and we calculate the confusion through this calculation by taking the data frame indexes is cancer, is healthy, and set the columns as predicted cancer and predicted healthy. And when we call the confusion, we got the confusion matrix. And if we set the heat matrix, this cancer is 66 and his cancer is 66 overall 66, and predicted cancer is 66, and predicted healthy is 0. And there are 48 with healthy, and there are 8 is predicted as cancer. So that is false, no? And so then we get the accuracy and those precision values, recall value, fun score that we need to take. Here you can see 0 to 1 at the 0 level, 1 precision value, recall value 0.83, F1 score is 0.91. And at the 1.0, 0 is 89, recall is a 1.0, and F1 score is 0.94. And accuracy value you can see 0.93. As we can see, our model did a very good job in the predictions. It has 93 accuracy. Further, we can increase accuracy using normalization. Then we set the ROC curve, and we can see AUC value of 0.9. If this is equals to closest to 1, that is much better. So this is a very good value. And then we consider the ID3 model. Here we imported the ID3 model. as just like the SVM calling the SVM model, we call the ID3 model from the scalar and set the confusion matrix. Here we can see 64 predicted cancer and 2 predicted health. But is cancer is head. There are 2 is wrong. And here also 5 is wrong. Predict healthy 5 is predicted as cancer. And for this part, for the ID3 model, here we got a precision of 0.96, equals 0.9, 0.92, and for the 1.0 precision is 9.3, 9.0, 0.97, 0.95, and accuracy is 0.94. Here, accuracy is little bit more than the above SVM model. And after the plotting the ROC curve, we can see AUC of 0.93. We can see ROC value in the other one is 0.98. So that one is better than this one. And there we select, we set the, we select, we coded another algorithm. We coded this SVM and ID3 algorithms to other dataset called CIFR10, Cipher10 images. Here we in this code we call some libraries like OS, Time, NumPy, and Matplotlib. And using the Keras library, we imported the cipher. Yeah, using the Keras, we imported the cipher, and we trained the model, define one and train the model, and normalize the. We can see normalize the data set here. Here we define the needed values for the training the model, and here we train the model, and then after train the model, we check the accuracy for the SVM model. Accuracy of 0.29, therefore SVM model. And for the ID3 test, we got the accuracy of 0.8. For this CFR data set, we got different accuracy values, and it is better for the SVM value 0.29. So thank you for the watching my video. Thanks.